lateral surface development of part P of a hexagonal pyramid as shown in figure. With side of base, with the base side 30 mm and height of axis is 70 mm. Okay, this was a problem. So generally he just gives my part P now. This was part P. Okay. So this inclination is given 60 degrees. This was a part P. So that means he just assumed, so this is going to be your cutting plane. So hexagonal pyramid. So he didn't give any simple position how the pyramid is going to be resting, or in which it is going to be resting with the edge resting or corner resting. He didn't give, but he just gives final front view of the part P is given. So if this type of part is given, means this was the front view. Okay. So this was a part P, and the section plane is supposed to cut your pyramid in front view like this. Okay. So this was a retained portion actually. So actually the pyramid is going to be like this. Let us assume the pyramid is going to be like this. But it is going to be, the retained shape is going to be this, and removed portion is this. So this portion is to be developed. So first of all, if we are supposed to develop, means this was a pyramid. So first of all, we just know the simple position and we just require the points. Okay, students, how do you understand the problem? So given the problem, draw the lateral surface development of part B of a hexagonal pyramid as shown in figure, with the base side 30 mm and height of the axis is 70 mm. Okay, given the part B is going to be like this. If your part B is going to be like this, how can you put the simple position? This was a hexagonal pyramid. So you just had to assume. So when your part B is going to be in that manner, so how your front is going to be appeared. Okay, students. So now let us see. So the part is going to be like this. So when your part is in this pattern, so how can we know what was the simple position? So in which position the front view is going to be applied like this. For example, if you just consider if it is your XY, so he just gives the hexagonal pyramid. So either hexagonal pyramid, there are two conditions. Either it should be the edge resting problem or corner resting problem. If it is a edge resting problem, let us say the hexagon is going to be like this. If it is a edge resting problem, base is resting on the HP. So when you are supposed to see the front view, what is going to, it is going to be having only three edges. So if it is going to be the pyramid is going to be obtained like this. So but your front view is going to be not like this. So this is going to be the not the correct consideration. So what was the next consideration? We know that. What was the next consideration? Either it should be the edge resting or corner resting. So this was the edge resting. Let us see corner resting. So if it is your corner resting, so let us consider if your points are going to be obtained like this. Okay, and this is going to be your axis, and you are going to be obtain your pyramid like this. Yes. If you see like this, you are going to obtain four solid edges and center axis. This was going to be the consideration, and your cutting plane is going to be obtained like this. So this was your cutting plane like this, and this was the retained portion of part B, and we are supposed to develop this. So the initial condition, the basic construction for the simple position is going to be considered like this. This is not to consider. Why? Because we are having only visible three edges. Here we have 1, 2, 3, 4 visible edges. So it should be the base is going to be resting as like the corner resting, or one of the base edges parallel to VP. Okay, students, clear? So how can we consider the simple position? Is it clear? The consideration is going to be the first one or second one? Which one is the considerable for the simple position? First one or second one? So obviously, so this was the consideration. Why? Because we are having 1, 2, 3, 4 edges, 1, 2, 3, 4. Okay. Okay. First of all, let us put the simple position. So there is no need of this much of XY line. So first this was my XY. Okay. So such that, so what was the initial condition? The base is going to be resting on HP. Okay. So this was the hexagonal pyramid. So this becomes your O1 of O2. Okay, this was the apex. All the corners are supposed to meet at apex. Corners are A, B, C, D, E, F. So given what was the base side? Base side is given 30. And what was the height of the axis? Height of the axis given 70. Okay. Now let us put the points which are going to be obtained on the base. Okay. So this is O1 dash, this is O2 dash. Okay, this was my base which is obtained. So tell me the points which are going to be obtained. This was A dash, this was B dash of F dash, this was C dash of E dash, and it is D dash. Okay, so this was a simple position. Next one is how your cutting plane is going to be. Your cutting plane is going to be given, so which is at a height of, so this is going to be given in the problem itself. He just gives it is 35. So when it is 35 means it was total height of the solid is 17. So this cutting plane is going to be half of the way it is parallel to XY at a distance of 35 from the base, that is at center. So let us consider if this is the center, your cutting plane is going to be like this. Okay. Now give the numbering for these points. This is 1. So one point which I forget to discuss, or I think I discussed. So whenever you are going to be obtain the double points, so when your cutting plane is supposed to cut the base edge, okay, you are going to obtain 2 points, and whenever it is going to be taking sudden change in its direction also, you just go for the giving number. Understand? So if your cutting plane is going to be like this, there is no problem. If your cutting plane is going to be like this and goes like this, so this was the change of direction. When the change of direction is going to be taking place, give number for it. Students, when your cutting plane is going to be change its direction and moves another way, so just to take that point as going to be the number. Okay, so just remember that whenever your cutting plane is going to be changes its direction at a particular point, you just consider that point also and give the number. Okay, now the first point is going to be 1, second point is going to be 2, which is here. Next here it is going to be the axis, but I am supposed to give the number for the change of direction, that is 3. Next this becomes 4. Next this becomes 5. 4 and 5. Next I just comes to the reverse opposite direction. So left to right, again right to left. So here this is OE is invisible edge, so that becomes 6. Next again change of direction is going to be taken place in this way. So while you just start from left to right, when the 3 point arises, it goes to be change of direction. I give the 3 point, and it's going to be in this pattern, and again it comes back. So when it is going to be comes in this direction, again it is change of direction. So here also you just give the number, that is 7. Next this one is 8. Students, is it clear? Students, is it clear? How can we obtain the points 3 and 7? Okay, right. Now project the points to the respective positions. So where the 1 point is going to be, there is no need. For example, here he didn't ask the drives the front view, drive sectional top view, he didn't give it. So directly I go for the final construction. If we ask for the development of lateral surface, and also we want to represent its front view, draw its sectional top view, then only we go for construction of the sectional top view. Here there is no need of sectional top view. He just asks the draw the lateral surface development only. So I directly go for the lateral surface development. Okay. So how can we go for the lateral surface development? This was a pyramid. So pyramid, what was the first condition? What was the first condition? Let us take true slantage. So let us take the true slantage. What is the true slantage here? What is the true slantage? OA and OD are the true slantage. So I just consider my OA. Just to consider OA as my true slantage. Let us consider this is O dash, this is A. Let us consider O dash, A dash as radius, draw a line, and with radius of O dash A, draw an arc. With O dash A as radius, O as center, draw an arc. What is this O dash A? O dash A is equal to length of true slant edge. So what are the true slant edges here? O dash, O1 dash, A dash, or O1 dash, D dash. These are the true slant edges. TSL means true slant length. Okay, true slant length. Okay. Let us consider TSL, true slant edge length. What is the true slant edge? So here O dash A, O1 dash A dash and O1 dash D dash is your true slant edge, and this is going to be true slant edge length. Okay, true slant edge length. Now let us take what was the given side, 30 as side. Now A as center, 30 as radius, draw an arc. 30 as radius, draw an arc to obtain B. 30 as radius, C. 30 as radius, D. 30 as radius, E. 30 as radius, F. So that becomes again A. So now close the sector OA. Okay. Now join the, now tell me what is the retained portion here, what is the part P here. This was my part P. Then what is the retained portion? Retained portion is nothing but, so this was the retained portion. This portion was retained. Okay, so that means total ABCD base is visible. So this was drawn with the straight edges AB, BC, CD, DE, EF, and FE. You just join AB, BC, all are straight edges. Why? Because the base edges are straight edges. Okay, all of these going to be straight edges. So I just join all the edges. Now let us draw all the slant edges from the apex. That is OB, OC, OD, OE, and OF. So these are the slant edges. Okay. Now project the points which are obtained at here on the respective positions. Now let us see what was the condition for pyramid and cone. Let us transfer all the points to the true slant edge and take the distances from apex to the true slant edge point and put it from the apex to their respective position. So here one is going to be already existed on, true slant edge, that is O dash, 1 as radius, draw an arc to obtain 1 point. Next 2 point. So 2 point is not in true slant edge. So if you just project that point to here, it reaches to 1 only. Why? Because 1, 2, 3 are going to be lies on the same horizontal line. So the distance from the apex is going to be same. So you just put your B is also with same distance, that is same radius. This is 2. Okay. Next, with same radius, 3 point is going to be obtained. Where this 3 point is going to be obtained in general? Okay, now let us see. You just hold on for 3. Next, let us see 4 point. 4 point is going to be on 4 point on OC. You simply project that point to the true slant edge. What was the true slant edge? Either OD or OA. So I just projected here. This becomes your 4. You just take the radius of O1 dash to 4 and put it on OC. Right? OC is the edge. So this becomes your 4 point. Okay. Next, 5 point which is already existed on the true slant edge OD, you directly take that radius, and so this becomes your phi. Okay. Next, the 6 point which is going to be on the same on 4, which is going to be draw horizontal to the true slant edge. So 4 comma 6 comes to the same point here with the same radius O2 6 as radius. It should be obtained on E. So this was your 6.6. Next is 7 point. Let us leave that 7 point. So which is on axis. You just leave it. Next 8 point. 8 is going to be on the same point of 1 radius. Why? Because this 2, 8 and 1 which you draw the horizontal, it meets the point 1 on this slant edge OA. So I just take the radius of O1 which is equal to O2 and O3. O8. Okay. 8 point is obtained on 8 point is obtained on EF. Okay. Okay, and again this was OA, this becomes your 1. Next, our requirement is 3 and 7. For points 3 and 7, you just do one thing with O dash 2 as radius, draw an arc between the 2 and 4 and draw the perpendicular bisector. For it we get number 3. So that means if you simply all of you just see, if you just take O as center, O2 as radius, O as center, O2 as radius. If you let us consider, this was only for my reference. I just draw up to O4, up to that is OC. Okay. If you just draw the perpendicular bisector for this, I obtain a point. This point becomes your 3. Okay. Similarly, O dash 8 as radius, O dash 8 as radius. So draw an arc up to OE and draw the perpendicular bisector for it to obtain 0.7. To obtain 0.7. Students, has it clear? So O dash 2 as radius and O dash 8 as radius. Draw an arc up to OC and draw perpendicular bisector for obtaining 0.3. Similarly, draw an arc up to OE and draw perpendicular bisector for obtaining 0.7. Okay. Now join all the points. 1, 2, 3, 4, 5, 6, 7, 8 and 1, and it comes to here. Okay. So the edges which are within the part P are going to be visible. So these are 2, 3, 4C, 5D, and so this was 8F. Okay. So this was your 7 and this was your 3. That becomes your part P. Okay, students, is it clear? Is it clear? So do you have any doubt? You just ask the point. If anyone having any doubt. Where is your doubt, students? Someone had put their thumbs down. So where is your doubt? What is the point that you didn't get it? Which point you didn't understand? Students, what was your doubt? Tell me, anyone, is there any doubt for you? What is the doubt? If you have your doubt. Yes, okay. I just repeat the problem. So he just gives the problem is going to be like this. For example, what we just see, he just gives the problem in this manner. He didn't give the problem clearly. He just gives it as like this. The problem is going to be like this. He just gives it as height of the axis is given 70 and this is given some 35. And he just gives the inclination, that is, if the inclination is going to be like this, so this is going to be making an angle of 60 degrees. We just concept in that pattern, that was 60 degrees. Okay, so this was my part P. Okay, so that was a part P to develop. So how can we understand the problem? What was the basic condition? So how the base position needs to be? So first of all, we had to construct like this. How can we construct? By seeing the front view like this. So we just have, this was known as, which was a hexagonal pyramid. So if it is a hexagonal pyramid, we have two conditions. Either it should be the edge is going to be like this, XY. If your edge is going to be like this, okay, or another condition is like this. So if you draw the front view for this, your front view is going to be obtained as like this. For this, the front view is going to be obtained as like this. So now from this, how can we consider the which basic position is going to be considered? So that means, so if it is considered, then you didn't get any axis. Why? Because the 3 points are going to be visible when you are going to see from the front. You obtain only 3 edges, but here 1, 2, 3, 4 edges and center axis. So how it is going to be possible? If I consider the position like this only, you will obtain your part P like this. So for that only, I just consider my problem is going to be the corner resting or one of the edge parallel to BP. So this was the consideration we had to taken. So let us draw the simple position like this. With the base side of 30, I just construct the top view. From that, I obtain my front view. Once we obtain the front view, I know this section plane is going to be in this pattern. It comes, come like this and it just moves like this. So the inclination is going to be from the axis is going to be taken as 60 degrees. So where it is going to be possible, it is taken at a height of, 35. Okay, I just mark a point of 35 from the axis, and from there I just draw the horizontal, and then I draw a line of inclination which is 60 degrees with horizontal. I just draw like this. Okay, so if I draw like this, then what is going to be, actually the pyramid is going to be like this. Actual pyramid is going to be like this. So, but this was the part B. So, what was the retained portion? What is the removed portion? When the observer is here, this portion is removed, and this is going to be my retained portion. This was my retained portion. So, further only, I just consider my retained portion, and wherever the points are going to be obtained, so that means wherever it is going to be get cut the edges, I just consider that point. So, this was 1, 2, 3, 4, 5. How can we obtain the points? So, let us see. 1, 2. So that means starting from X cylinder, the first point is 1, which is cuts on OA. Next B point on. So OB is going to be cut by 0.2. Next 3 point. So this 3 point. So why this 3 point is on axis, sir? So that was not the point on axis. whenever your cutting plane it takes the change of direction. Okay, so that means if your cutting plane is going to be passing like this, no problem. If it is passing like this, that's also no problem. If you pass like this, no problem. Whenever your cutting plane is comes like this and moves like this, okay, if this cutting plane is going to be like this, then wherever the change of position is going to be considered, there also you just give the numbering. So for that only, so the cutting plane comes up to here in horizontally and takes an inclination. So I just give numbering as 0.3. That means change of direction taken place, you just give the numbering. Similarly, next 4 and 5, again starting from no, right to left. So 6, again second, why is 7, sir? So again the position of the cutting plane comes in this manner, again it changes the direction. So I just give the 7. So 3 and 7 are going to be the points which are obtained for change of direction of the cutting plane. So left to right the point 3 is obtained, right to left it is going to be 7 is obtained. Okay, 1, 2, 3, 4, 5, 6, 7, 8. And I just take the true stand edge length, O dash, A dash as radius. I just draw a line. Okay, and O dash A as radius, draw an arc. And how can we divide it, sir? So how you divide 6 parts, sir? So for hexagon, how many base edges are there? 6 edges. So 30 as radius, A as center, draw an arc, draw an arc, draw an arc to obtain 6 parts. Okay. So A, B, C, D, E, F, and A. So starting and ending are going to be same as we discussed in development. Whatever the edge we are supposed to start to unwrapping, so that we are supposed to end at the same position. That means if we start from OA, we end up to OA. Now project the points to the respective positions. So in pyramid or cone, what was the first condition to represent the points on the respective position? First of all, check whether the points are in true slant edge or not. What is the true slant edge? Here OA, OD are true slant edge. So project the points on the true slant edges if they are not in true slant edge, and take the radius from apex to the true slant edge point and put it to the respective position. Here 1 and 5 are already in true slant edge. So 2, 8, 4, 6 are not on true slanted. So I just project the point up to here and I just project the point up to here. So this becomes 2, 8 at the same consideration. Why? Because if I draw the horizontal up to the point 1, which is projected on true slant edge OA, so that becomes the common point as 1. So the radius is constant. Why? Because it is a horizontal. Okay. Next, similarly, 4, 6 are going to be also projected to the what is true slant edge. So this becomes up to here it is 4, 6 and it is 2, 8. I just take the radius of the apex from the on the true slant edge to the point to the apex as radius and put it from the respective position. O1 as radius on A, O2 as radius on OB. Let us leave 3, 7. O4 as radius on OC. O5 as radius on OD. Next O6 as radius on OE. Okay, 4, 6 are projected on the true slant edge. I take the radius from the true slant edge to apex and I just place it here. Next I obtain 1, 2, 4, 5, 6, 8, 1. Now I require 3 and 7. So simply you just do O as center, O2 as radius, O dash 2 as radius, draw an arc up to OC and draw the perpendicular bisector for that arc to obtain the point 3. Similarly, OD as radius, draw an arc up to the edge OE and draw the perpendicular bisector for that arc. So to obtain the point 7. Once you obtain all the points, join all the points. So we already know that. So part P means total bases existed. So it is going to be drawn with the edges. Okay, this was not the curve as like cone. So for cone, you are going to be obtained as like while coming to here, it is going to be edges like this. Okay, if it is a cone, you are going to be obtained smooth curve. While coming to here a hexagon, it is going to be come like edges. All edges are going to be joined to the apex like this. Okay, students. Now 1, 2, 3, 4, 5 also going to be retained. So 1A, 2B, 3C, sorry 4C, 5D points are going to be joined with the slant edges. So those are also going to be get highlighted. Okay. Okay, students. Is it okay? Make it fast. Students, can I erase this? Can I erase this problem? Can I erase this problem? Students, can I erase this problem? Students, all of you just remember that. So if it is a pyramid, all of you see, if I just take my true slant edge is going to be here O dash, and if it is A, if I just draw the arc like this, okay, Okay, students. So a pentagonal pyramid, side of base 30 mm and axis 70 mm is resting on HP with its base, and one of its sides is perpendicular to VP. One of its sides is perpendicular to VP. Next, you just consider a string is wound around. A string is wound around the surface of the solid. So the string means, let us consider a rope is wound around. So from where it is wound around, let us consider it is going to be, pentagonal pyramid is going to be resting on ground such that one of the edges is perpendicular to VP. You just place like this. And now what was the extreme right corner? This was the extreme right corner. I just take one of my string, one end is going to be connected to the extreme right corner, and I am supposed to make it wound around and comes to the initial position D. Okay, students, my pyramid is going to be like this, such that one of the edges perpendicular to VP and the extreme right corner is going to be this D. I just take a string and I am supposed to wound around and again comes to the initial position. Now let us make, he has to develop the lateral surface and go back to the initial position D. Find geometrically what was the shortest string required. So what was the shortest string required means, what is mean by that? It was the displacement. What was the displacement? It is going to be required to show the path of the string. Let us see. Let us first of all put the simple position. XY. So one of the edges is perpendicular to VP, right? A, B, C, D. Compulsorily you have to take this point as D. You are not supposed to take some A, B, C, D. This becomes C. Why? Because extreme right corner he just gives D. So we have to consider this was D and E to obtain the apex point. So this was your apex while you are seeing from top. O1 of O2. What was the given side? Given side is 30 and height of the solid is given 70. Okay, so these are the front view points. This becomes base is completely visible. Okay, so this becomes your B dash of A dash. So this becomes O2 dash. This is O1 dash, and this is C dash of E dash, and it is E dash. Okay, so this was your apex point. Now how can we obtain our string is completely wound around? So this was the just a reverse mechanism. I don't know how it is going to be obtained when it is wound around or comes to here. So first of all, I just develop the lateral surface and I now find what was the shortest distance. Now tell me what was the slant edge here, true slant edge. Let us consider this OD is going to be your true slant edge. Why? Because this was a pentagonal pyramid. You are going to obtain okay. So this becomes your slant edges. Okay, and these are going to be the front view and top view. Now I know that OD is the true slant edge. Let O dash D dash is true slant edge. Okay, so now I just consider I just consider O dash D dash. Why? Because my starting point is D and again comes to the initial position. So first of all, I just draw the line of D. This is O dash and D. And if I am supposed to draw an arc, now take the radius of 30, D as center, draw an arc. Another 1, 2, 3, 4, 5. Okay. And mark the points are. So starting from here and again comes to here. Okay. So let us consider D, E, A, B, C, and again comes to D. I just join OD. Next, this was the pentagonal pyramid. Base edges are straight edges. So join D with E straight edge, E with E straight edge, A with B straight edge, B with C straight edge, C with D straight edge. Okay. Once you obtain a edge, you just remove just arc which we drawn for the radius of OD. So this becomes your straight edge. Okay. Now join all the edges OE, OA, OB, OC, and D. Now tell me what is the shortest distance to make it wound around D to D? When I just take from here is going to be my string, and if it is going to be completely wound around and comes to the initial position So then what was the shortest distance? Shortest distance is nothing but your displacement. So let us consider the joining line D to D. So this was the shortest path. So I can go from anywhere. I can come from here to here to here to here also. I come to here or here to here, anywhere. I just travel. But what is the shortest distance? If you draw a straight line joining D to D, that becomes your displacement. So join D with D. Displacement always means the shortest path. Okay. Now let us mark the points. Okay. So here the point is 1. This is 2, 3, 4, like this 4. Again it is 5. Again it is going to be 1. This point is going to be 1. Now let us put your points in this diagram. Okay. So that means D is going to be your point 1. Next, where the 2 point is obtained, where the 2 point is to be obtained. Where the 2 point 2 is on OE, 3 is on OE, 4 is on OE, 5 on OC, and again 1. Now, what was the reverse mechanism? Actually, what we did in the previous problems, whatever the cutting points which are obtained here, we just project the points to the true slantage and put it from the respective positions. Same, I just consider here OD is my true slantage. So I just project my points to the true slantage. So, okay. So that means you O2 as radius drawn to obtain at here. So this becomes your point 2. Next, O3. This is only for my reference. Okay. Again, 3 is going to be, you just draw. So this becomes your 3. Similarly, you just take it as, so that means your 2, 5. And 3, 4 are going to be comes at the same points. So that means 2, 5, - 3, 4, which are going to be obtained on same length actually. Okay. So simply if you just project this, so the 3, so this 3 and 4 will comes at the same point actually. When you just draw an arc like this, you just draw an arc with the radius. It will come like this. This becomes, and if you take 5 as going to be the radius, this comes at here. Okay. Now let us take this distances from fx to this and put it from the true slanted. So where the true slanted? So this becomes your 2 comma 5, and this becomes your 3 comma 4. Students, is it clear? Students, is it clear? First, how can we obtain the points? Once we obtain the points, let us see. So what is the shortest path from D to D? That was nothing but, it's a displacement. So I just join this D to D with a straight line. Now mark the points 1, 2, 3, 4, 5 and again 1. Now the procedure in previous is we just take the distances from fx on true slanted and put it from here. This was the reverse mechanism. From here to here I am obtaining the points. Same, the points which are going to be here are to be projected on the true slanted as O as center, O2 as radius, draw an arc up to here to obtain 2. Next, O as center, O3 as radius, draw an arc to obtain 3 on the true slanted. Why? Because OD is the true slanted. Next, if you draw 4 as radius, it comes to the 3 comma 4 and O5 as radius drawn arc, it comes to 2 comma 5. Same points. These are the same points if you just rotate it. Okay. Now let us take this distances from apex and put it from here. So O2 as radius, O as radius drawn arc to obtain 2 comma 5. Similarly, O3 as radius on the true side and put it from here to obtain 3 comma 4. Now project the points to the respective positions. Let us say 2 point is on OE, right? So if you just draw the arc like this, if you just draw an arc, so if you just draw the horizontal, that means you simply draw the horizontal, your point comes at here. This becomes your, that becomes your 2. Next, 3 on OA. So this becomes your 3. Okay. Next, 4 point is on OB. So this becomes your 3 comma 4. Next, 5 point is on OC. So this becomes 2 comma 5. Or now join the points 1, 2, 3 and 4 like this. You are going to be obtained like this. Okay. So that means this was not this section. This I am not making section. So I just make it wound around. That means there was no section and no 2H pencil or 3. All are going to be, this was HP pencil. All edges are visible. Here also you see this was visible. This was the thread which is going to be the straight line. Okay, all was visible. This was a string. Similarly, this was completely visible and this was a string. Okay, and just when you're supposed to see from the top, you see the total wounding position by projecting the points to the respective position 3 comma 4, which is on B and A. If you draw the vertical projector like this, so B point you are going to be obtained. This is 3, and this is 4, and this is 3. Next, if you draw the vertical projector like this, so this becomes your 2, this becomes your 5, and here it is going to be your 1. Okay. Now join all the points. So this becomes okay. So this becomes your 2. So when you see from the top, you just see like this. So it was completely wound around the solid. Okay, students, is it clear now? Is it clear? Students, let us see what this was not a typical procedure. Why you are not able to got it? Let us see. Up to here, you got it right. Points are going to be projected on the true slanted by taking this radius, and I just take these points and put it here. Whatever the mechanism which we done in previous, it was just a reciprocal reverse mechanism. I just have my points and put it here in previous. I just have my points at here. I just get it to here. So how it is means transfer the points to the true slantage, and from then you just project it to the respective positions. So here it is going to be the true slantage. The points which are going to be obtained, I place it here, and simply if you just draw the horizontal, then you will obtain it here. If you draw the horizontal, then you can obtain it here. So where your 3 point is on OA, so on OA you are going to obtain your 3. Let us see, 3 point is on OA, 2 point is on OE. So the problems is going. So here all of you just see this becomes your, just see, 1. All of you just see how can I obtain my points. Now let us see. Is it clear up to now? Up to now is it clear? My 1 point is on directly on D, so I get my 1 at here. Next 2, 5 on, I just O as center, O2 as radius, draw an arc. This was an arc. All of you just consider this was an arc. Similarly here also an arc. When you draw an arc, you obtain the points at here. This was the true slanted. So take these points radius and put it from here to obtain the points. Once you obtain the points, you just draw the horizontal to the respective position. 2 and 5 are on, 2 and 5 on E and C. So simply draw the horizontal up to here. Similarly, from 3 and 4 are on A, and 3 and 4 are A and B. So simply you just draw the horizontal from here to obtain it here. Once you obtain the points, project the points to the respective position. 1 point is on OD, so directly on D, no problem. 2 point is on, 2 point is on OE. Let us see OE, though this becomes your 0.2. Next, 3 point is on OA. So here it is going to be OA, this becomes your 0.3. Next, 4 point is on OB. If you draw the vertical projector at here, it meets at here, this becomes your 4. Next, 5 point is on OC. So 5 is on OC. So this becomes your 5. Join all the points to obtain the curve. So this is nothing but your string is completely wound around when you are see from the top. If you are supposed to see from the top, you see that the string is going to be completely wound around. Okay, students, is it clear now? Is it clear now? Make it fast. Make it fast. Students, can erase it? Students, can erase this problem? Had you copied? All of you just write a problem. Draw the lateral development of surface. For cylinder, whose front view is given. Okay, so the problem is going to be like this. This was a portion to develop for the cylinder's front view. So height is given 100. Height is given 100 and base is given diameter 60. Okay, and the inclinations are 30, 30 and 40. This is 30. This is also 30 degrees and here it is 40 degrees. So this was my part B. This was the part B. Students, is it clear now? That was the problem. So he just gives the part P and we just had to develop. So when your cylinder front view is going to be obtained like this means, so what was the basic position of that? What was the basic position when your cylinder is going to be resting on HP only? Your front view is going to becomes as a rectangular surface in front. Okay, so that means top view gives the true shape. Okay, let us see. Okay, so for my convenience, I just divide my circle into 8 number of equal divisions, right? Okay, so this becomes A, B, C, D, E, F, G, H. So cylinder which is top base is visible, bottom we have another base, this is P, Q, R, S, T, U, V and W. So this becomes your O1 of O2. What was the diameter of the base which is given? Diameter 60 and height of the axis is given which is 100, right? Okay, so let us project the points in front view. For cylinder, generally we just highlight only the end generators. Okay, actually we just highlight only the end generators. So for our convenience, we just have to make the intersection points also. Okay. So wherever these edges which are going to be considered as the reference generators also, we just give the numbering to those also. Okay. But just remember, only for cylinder and cone, we just highlight only the end generators. You just remember that point first. Okay. What are the front view points? It is A dash, B dash of H dash, C dash of G dash, and D dash of F dash, and it is E dash. Similarly, so here it is E dash, Q dash of W dash, R dash of V dash, S dash of U dash, and T dash. Now let us see where is our section. This was your part B. How can we obtain our part B? So from here I just draw a line of 30 degrees. From here I just draw a line of 30 degrees. Okay. So next, similarly from here also I just draw a line of 40 degrees. From here I just draw a line of 30 degrees. Okay. So now this becomes my part B. Okay. Now give the numbering to the cutting points. Okay. So first of all, let us start from the extreme left from this position. This becomes your 1. This becomes your 2. Next, this becomes 3. Okay. Next, this becomes 4. Next, this becomes 5. Next, this becomes 6. Next, this becomes 3, 7 and 2, 8. Next, this point is going to be 9. This is 10, 11, 12, 13, 14, 15 and 10, 16. So these are my points. Now let us, this was a cylinder which comes under the which procedure? This was parallel line method. So that means we just have to draw 2 stretch out lines. Okay. Stretch out lines. So which are going to be parallel to the, which is going to be drawn beside the front view, and it is, these 2 lines are like this. So this was my box. This was my box. Actually, I created this box like this. Okay. And what is this length of the box? So which is nothing but your perimeter, which is nothing but your pi d. This was pi d. Next, how can we divide this? How many parts we are going to be divided? So I just divide into 8 number of equal divisions. So you have to divide also into 8 number of equal divisions, right? So how can we divide it? You just go for the line division method and you just obtain the points of 9 and you just join them. Okay. So I just start from the 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8. Okay. Let us start the points. That is A, B, C, D, E, F, G, H, and again it is A. Similarly, it is P, Q, R, S, T, U, V, W, and again P. Okay. Now project the points to the respective positions. Let us see, one point is on at here. So if I just draw the point, so this becomes your 1 and it is also my 1. Next 2 point. So this becomes my 2 is on QB2 and 8 is on HW. So this becomes your 8. Similarly, 5 point is going to be, so let us say 3 point. 3 point is on CG, right? So that becomes, the C becomes your 3 and G becomes your 7. Okay. Next, 5 point is on ET. You draw a line. So this becomes your 0.5. Next, 6 comma 4 at here. 6 comma 4 in, so this becomes your 4 and this becomes your 6. Okay. Next one is 9 is going to be at here. This is 9 and similarly this becomes your 9. From here draw the horizontal. From here draw the horizontal. From here and from here. Okay. Now mark the intersection points. So this becomes your 10 and similarly W it becomes 16. Next it becomes sorry, this is 10. The V, so it becomes your 15. Similarly, 12. 12 is on S, so this becomes your 12. So this becomes your 14, and this becomes your 30. Now join all the points. So that means 1, okay, students. And for cylinder, you just highlight only the end generators. So you just highlight this only. Okay. Now this becomes your part P. This becomes your part P. Okay, students. For cylinder, we just highlight only end generators. Is it clear now? Students, can I move to the next problem? Students, can I move to the next problem? Students, had you completed? Can I move to the next problem? Why so many people are just left the session? So just half an hour back I see around 140, now it is only 113. What happened? Only 113. So I just see another 30 members had gone left. I left the session, 30 members. So can I erase it? Can I erase it? All of you just draw the problem. Draw the lateral development of part P of cone whose front view is given, whose front view is shown. So the cone is going to be, the front view of the cone is going to be generally like this. It just gives it as okay. So total base is going to be of diameter 50. students? Okay. Okay. So that means we already know that when your cone is going to be resting with its base on HP, only you are going to obtain your front view like this. The problem is given front view like this, and we are supposed to develop the part P. So when your cone is resting with its base on HP only, your front view is going to obtain as a triangle. So which view gives the true shape, top view gives the circle, and front view gives the triangle. So I just consider my top view is going to be circle, okay, and front view is going to be my triangle. So I just put the simple position that axis is perpendicular to HP. Top view gives the true shape, front view gives the triangle. Okay. Now let us place my point part P. How can you obtain my part P? He just gives it is 30 degrees from here. So I just take this corner and draw a line of 30 degrees. This was 30 degrees. And he just gives this was going to be from apex, it is 20. So from apex, I just take my 20 and I just draw the horizontal. So this becomes my part P of the front view of the cone. So how can we develop this? First of all, we just place the points of the cutting points. Let us see what are the section points. Let us see. Start from extreme left. 1, 2, 3, 4, 5. So this was the cone. We just consider 8 generators for obtaining the smooth curve. Generally, when we go for projection of solid, we just have only end generator only. While coming to this development and sections, we just consider generators also for the numbering. Why? Because to obtain the smooth curve at here. So for that only, I just give the points to the and not only n generators, in between generators also 1, 2, 3, 4, 5, and 6, 7, 8. Okay, so left to right it is 1, 2, 3, 4, 5, and again we come 6, 7, 8. Why? Because two edges are there. Here it is 2 edges. Okay. Next, similarly, this is 9, 10, 11, 12, 13, and again comes in this direction. We have again two edges 14, 15, 16. So these are the points. So I just had to convert development for this part P. Okay, for that I just go for this was a cone. It should be drawn with the help of theta, which is 360 degrees into R by L. Okay, now divide your 138 degrees, draw the true slant edge. Let us take your true slant edge and draw an arc with that radius and close it for the sector of 138 degrees generally. Okay, let us see. Okay, let us see. So this one, if it is going to be your O dash and it is A, I just draw an arc such that this becomes 138 degrees. Again, this is A. How many parts I should make this sector into 8 number of equal parts? So let us take for angular bisector method with any two convenient radius, draw two arcs. With these centers, you will obtain two arcs. That becomes your angular bisector. Again, you take these two as sectors, you will obtain angular bisector for this. So 1, 2, 3, 4. So again, I just make angular bisector. So I obtain 8 parts. Okay. So let us give the numbering as A, B, C, D, E, F, G, H, and again A. Now again, what was the condition for the development? Always project all the points to the respective positions on the true slanted and then put it from here. So let us see 1, 2, 3, 4, 5 all are going to be on the straight line where your one point is also on the true slanted. So when you project this point, all comes at the same reference point as one radius. So I just take this as radius and I directly put my points as going to be so 1. So OA it is going to be this becomes your 1. Similarly 2, 3, 4, 5, 6, 7, 8, and again it comes to 1. Okay, students, is it clear? 4, and again this becomes your 5, 6, 7, 8, and again it becomes your 1. Next, similarly, 9 point is at here, this becomes directly 9. So this is also 9. Next, 10, 11, 12 are going not on the true slantage. So project those points to the true slantage. Project those points to the true slantage. This becomes your 10, 16. So this becomes 11, 15. So this becomes 12, 14. Now take the radius from the true slantage. So this becomes your 12, 14. Okay. Now let us take the points where your 10 is going to be on OB. So you just take the radius from the true slantage and put it from here. So this becomes your 10. Similarly 11. Next 12. Next this is 13, 14, 15, 16. Okay. Now join all the points. Similarly, it is going to be obtained like this. Okay, so for cone, you just highlight only the end generators. I now highlight these two end generators. Now this becomes my part B. Okay, students, is it clear now? So you just there are only 2 points to remember. First of all, whether the points are going to be on the true slantage or not. No, if the points are not on the true slantage, project the points to the true slantage. Once you obtain the points on the true slantage, take the radius from apex of that point and where the position is going to be, and you just locate from apex to the particular position. Okay, this was the only thing you just remember. Remaining all the procedure is same as like section of solve. We just place the points. Once we place the points, you just take the radius of the apex to the point and put it from the respective position. Once of all, let us see only the points are in true slantage or not. If they are not in true slantage, project the points to the true slantage and take the radius from the apex and put it from the respective positions. Okay. Is it clear, students? So all of you just note the problems in textbook which you are supposed to do. So we are not supposed to do all the problems. So kindly you just take these problems. All of you just note these problems. Problem 15.9. Problem 15.9. All of you just note these problems. These are very important problems. 15.9. Problem number 15.7. 15.7, 15.8, 15.9, 15.9, 15.11, 15.11, 15.13, 15.13, and 15.14, 15.14, 15.17, 15.18, 15.18, 15.19, 15.19. Okay, so 15.23, 15.23, 15.24, 15.24. Okay, and in the exercise problems also, let us see the problems in exercise 15. You just see all the problems are of solved examples only. Okay, So kindly go through the problems on the chapter number 15, and what are problems which I dictated you, you just all of you had to do in your notebook or A4 sheets, whatever it should be. It should be your assignment. So I just given you some 8 number of problems. We just explained yesterday and today. We just explained 8 numbers. This was the total procedure to construct. So there are solid examples in your textbook of some 7 to 8 problems which I dictated you, and exercise problems are also there. You just go through and you had to construct at least 10 problems by your own. You can see the solved examples on it. That's not an issue, but you just had to construct at least 10 problems as your assignment. That is, you construct on your notebook or you construct on the white paper, whatever it should be. Okay. All of you had to do that, and you had to submit the assignment when the college reopens before the examination. Okay. So this was the end of the development of surfaces. This was the end of the development of surfaces. In next class, we see the isometric projections, isometric view, construction of isometric drawings. Okay, so all of you had to go through the textbook, endeavor textbook, and you had to solve the examples. Solved examples only. Don't get afraid. So those are solved examples only. You just kindly go through and construct. Okay. Students, someone had raised a question. What is it? Can I repeat the questions once again? Can I repeat the questions? Exercise questions. Can I repeat? Is it necessary to repeat the questions or it's okay? Okay. Okay, thank you. So someone has asking question. What is it? I means I means. Students who had raised some question. What is mean by I? I means. I didn't understand. What is mean by that I? Is there any doubt, student? Is there any doubt in this question? Theta value. So theta value means 360 degrees into small r by capital. This L is nothing but length of true slanted. So this length. So O dash E dash. O dash E dash or O dash E dash. So R is nothing but your radius. R is equal to radius. So given it is diameter of 50, so R becomes R is equal to 50. So for that only I just obtain like this. The value is 138. Is it okay? Is it okay? L is length of the true slant. You just measure it. Okay, students. Is there any doubt? Is there any doubt? Okay, thank you. So next class we will see the isometric drawings.